What's going on, guys? My name is Jade and this is your fourth computer graphics tutorial on circle drawing. Now in this tutorial I'm going to be showing you a new way of calculating the D, and which is known as the second order differences. Now you remember in the last tutorial that we had our del E to be equals to twice XP plus 3 and our del SE was equals to twice XP minus twice YP plus 5. Now, you remember how these two equations are variables due to the presence of XP and YP. That means we have to do some complex calculation. See? Now, these calculations, the multiplications, are kind of difficult for computer to do. I mean, it's obviously easier for them to do it in an additional way. So, what we are going to be doing is we'll be simplifying these equations to make it look close to a constant rather than leaving them out to be variables. Okay? Now, suppose this is our XP, YP. Okay? That means this is our E and this is our SE. So, initially our del E is equals to twice XP plus 3, and of course our del SE equals to twice XP minus twice YP plus 5 as before. Now suppose we have selected E. Okay, if we have selected E, what does that mean? This would become our new E, this would become our new SE, right? And our pixel would advance over here. XP plus 1, YP would remain the same. That would be our current pixel if we had chosen E, right? So at that point our current pixel would become XP plus 1 YP. In this case, what would our del E be? Our del E would be 2 into XP plus 1 plus 3. I'm just substituting the value of XP plus 1 into XP. Okay? That gives us twice XP plus 5. Now, suppose I call this del E to be del E old. Well, then this del SE to be del SE old. And this del E to be del E new. Now, if I find out the difference between the two del E's, what do we get? We have del E new minus del E old, and I'll just call it DEL. Let's just call it delta E. Okay, so delta equals this, and if you subtract the two, twice XP plus 5 minus twice XP minus 3, we get 2. Similarly, our del SE new would become twice XP plus 1 minus twice YP plus 5 if we chose the pixel E. So, if you do the calculation, you'll see that del SE new minus del E new, del SE old. So the del SE new minus del SE old, and let's just call it delta SE. Okay, and we have, by subtracting this one over here from this one, you'll get once again 2. Okay, so whenever we choose the pixel E, we update our value of delta E by 2 and delta SE by 2. Okay? Now, if we select SE on the other hand, then what do we get? This becomes our current pixel, right? So in that case, if SE is chosen, then this will become E right here, and this will become SE. And our current pixel would be XP plus 1, YP minus 1. See? So what does that give us? What does that give us indeed? So our current pixel would shift to xp plus 1, yp minus 1. Then our del E new will become 2 into xp plus 1 plus 3. Again, our delta E, which is del E new minus del E old. Of course, del E old is still the same before we chose either pixels. Now, this would give us, once again, 2. Okay? Now, if we choose SC, if we calculate del SC new, we get twice xp plus 1 minus twice yp minus 1 plus 5. With me so far? I just substituted the xp and yp with xp plus 1 and yp minus 1, since our current pixel has changed from xp-yp to xp plus 1 yp minus 1. So if you find the delta SC through calculation, you just subtract the del SE new minus the del SE old, so you subtract the old SE, and that would give you 4. You can do the calculation if you want, but that's the result it will give you. So that simplifies matters a lot. Now all we have to do is, if suppose D is less than 0, then we select E, okay? We update D by adding del E to it, okay? And of course we update our del E by adding delta E to it in case of selecting E, which is 2, okay? So del E becomes del E plus 2, and we also update our del SC to be del SC plus 2, because if we chose E, then our del SC difference was also 2, okay? On the other hand, if we have D is greater or equals to 0, then we select SE, we upgrade D by del SC, we update del SC by 4 by adding 4 to it, because in case of choosing SC our difference was 4, and we update our del E by 2. Okay, now these equations have become a lot more simplified. We have to just add a certain value to each of them, and we don't have to look at XPYP anymore. Of course, we have to know the initial values of del E and del SC. Okay, so let me just go ahead and remove all these. Now the initial del E del SC. Now, if our origin is at 0, 0, remember we always do our calculations by thinking our origin is at 0, 0, and our radius is r, then our initial XPYP is nothing but 0r, as I explained in the previous video, right? So in this case, our del E becomes 2 into 0, twice xp plus 3, so 2 into 0 plus 3, which is 3, and our del SC is twice xp minus twice yp plus 5, and twice xp is 0, right? Twice yp is 2 into r, because yp is r in this case, and of course plus 5, and this gives us 5 minus twice r. And that's about it. I'll show you an example as to how to calculate the pixels to be glown using this second order difference in the next video, and as for this one, we're done. See you in the next one.